In this video, we're going to look at the identity matrix. An identity matrix is a square matrix with the value of 1 in every element of its principal diagonal. That's the diagonal in a matrix that runs from left to right, and 0 everywhere else. So here's an example of a 3 by 3 identity matrix. Again, an identity matrix will always be a square. So we have 1s in all elements of the principal diagonal and 0s everywhere else. And then finally a 2 by 2 identity matrix. Properties of an identity matrix is an identity matrix multiplied by itself will just be the identity matrix. So let's multiply these two identity matrices together following matrix multiplication. 1 times 1 plus 0 times 0 is this first element. Then 1 times 0 and 0 times 1 is the second element. So remember, it's the row in the leading matrix multiplied by the column in the lagged matrix. And then down below here we got 0 times 1 plus 1 times 0. And then finally 0 times 0 plus 1 times 1. And it just leaves us with the identity matrix. Another property is if we were to take a matrix A and multiply it by an identity matrix, we just get back matrix A. So multiplying a matrix by an identity matrix leaves the original matrix unchanged. The identity matrix is like the number 1 in algebra. So here's matrix A. It's a 2 by 2 matrix, the identity matrix here. So doing the following: A times I, 6 times 1 plus 4 times 0, 6 times 0 plus 4 times 1, 2 times 1 plus 3 times 0, and then finally 2 times 0 plus 3 times 1. We get back the original matrix A. Another example, matrix A and its identity. Doing the calculations here, we just get back the original matrix A. Another example, an identity matrix multiplied by matrix A will just give us matrix A. An idempotent matrix is a matrix when multiplied by itself leaves the original matrix unchanged. So an identity matrix is an example of an idempotent matrix. Here is a non-identity matrix that is idempotent. So if we were to multiply matrix A by itself, you would just get back matrix A. So an identity matrix is idempotent, but other matrices can also be idempotent as well. All right, that's it. I hope you found this video helpful.